9 review on the Unit 10 review. That was kind of a mouthful. And it really shouldn't take that long because this was supposed to be part of the Unit 8 review anyways. So the first problem, I give you that you start with a certain amount of, I give you a whole reaction, then I tell you you have this amount of one reactant and this amount of another. So automatically, guys, since I'm giving you 2 different values for your reactants, you should automatically know that this is a limiting reactant problem, okay? So otherwise, I would say 21.6 of this and then excess of this. But since I give you 2 different quantities, you're going to have to convert both of them into grams of the product which you're trying to solve for, which in this case is C3H3N, okay, which you can totally do. So we're going to do the first one first. We're going to do C3H6. So you start with 21.6 grams of C3H6, okay? Then you're going to crisscross swoosh because I want to get into grams of this. So I'm going to put 1 mole of it, the C3H6 on top. Okay. And then I'm going to put grams of C3H6 on bottom, its molecular mass, which is 42 grams of C3H6. Then I'm going to crisscross swoosh. I want to convert into moles of C3H3N. So it's 4 moles using the mole-to-mole ratio of C3H3N. Okay, and then I'm going to put moles of C3H6 on bottom, which is 4 again. Okay, then my last thing I need to convert, sorry, my pen is malfunctioning. Then I'm going to convert into grams. So I'm going to crisscross swoosh one more time, go into grams. I need the molecular mass of C3H3N, which is 53, which you guys can calculate really easily, over 1 mole. Okay, and when I get there, is 27.26 grams. Okay. Next one I need to do the same thing but with nitric oxide. So I'm going to do 21.6 grams of NO, crisscross swoosh, 1 mole of NO on top, so I want to get into C3H3N, which is my product, 30 grams of that on bottom because that's its molecular mass, crisscross swoosh. The coefficient for NO is 6, so it's 6 moles of that on bottom. And 4 moles of C3H3N on top. Crisscross swoosh again, and it's 53 grams. Is the molecular mass over 1 mole. Now, the number of grams I get for this one that this one produces is 25.4 grams. So what you should notice, both of these produce different amounts of your C3H3N. This one produces more, this one produces less. Just like this more example, since this one produces less, this is how much is actually going to be made. Therefore, NO is your limiting reactant, C3H6 is your excess reactant, excess. Okay? Limiting. Okay, so your 25.4 is how much is actually produced. Circle that. Good. Now it says how many grams of excess reactant are left over. So I'm going to do it the typical way that I showed you guys in class. I take these 2 numbers, 27.26 and 25.4 grams, and subtract them. Okay. As you might remember, and I didn't correct this. I hope I corrected on your guys' papers. I don't know if I did. Maybe, maybe not. Anyways, this value, 1.86 grams, is what you get. Don't fall into my trap. This is 1.86 grams of C3H3N. I now need to convert into my excess reactant because that's what it's asking for, okay, which is C3H6, which I can really easily do. I'm just doing this backwards now, guys, so don't freak out and think you have a lot more work to do. I'm 1 mole of C3H3N. I'm trying to get back into the C3H6 really quickly because writing with this pen hurts my hand. 53 grams. Crisscross swoosh again. Put 4 moles on bottom. Notice, even though I'm writing with a really awkward pen, I'm still including all my units because not putting units is annoying for me because you guys then mess up. Ooh, I messed up right here. I'm just noticing this right now. Sorry, guys. This C3H6, that should have been, right? Sorry about that. So this should have been this should be C3H6 on top, and this is C3H3N, but I don't have space. You can write it. And this is 42 grams on top, and that's 1 mole on bottom. Alrighty, so when I do it, 1.86 divided by 53 times 4, divided by 4 is times 1 times 42. I get 1.47, and I'm hoping on my page I corrected this one to 1.47. If I didn't, I'm sorry. This is what I meant to be the answer. Okay, so the answer is C. Alright, next problem. So we're done with that finally. Please don't fall into this trap. I'll put this always as an answer. I'll put this as an answer, with the right answers, obviously, for your test. Okay, percent composition of water, meaning the mass of water over the total mass of your hydrate. So, the mass of water in this, I've got 5 molecules of water, so 5 times 18 is the mass of water, all over the total mass of this compound, of this hydrate. Okay, when you do that, guys, when you do the atomic mass of magnesium plus carbon plus 3 oxygens plus the 5 times 18, because you have to include the entire mass of the hydrate, you should get 174.13. And so you should end up getting 51.6%. That is your answer. Now, if you just write 51.6 on your test, I will give you no credit. I need to see work for all of this. So if you guys noticed on any review, if I passed it back and gave you a 0, it's because you put no work. Okay, I need to see work. I can't give you any credit with no work. All right? Okay then. Bye, guys.